This project was an extremely complicated project. Metal fabrication facility where a number of years ago there was a discharge to the environment. There was contamination of soil, groundwater, and vapor concerns.
They used a lot of lubricating oils for their metal goods, and they ultimately were using degreasing solvents, TCE, to degrease these finished metal goods before shipping them out. At one point, there was an accidental release in the building, and it ended up moving into the environment.
Migrated into bedrock,
which made the problem a lot more complicated. So we were able to excavate the soil outside of the building, but because the release was actually under the slab of the building, it's very difficult to remove the soil. Instead of allowing the vapors to get into the building, it's extracting them out of the soil and then sending them outside of the building and treating them. So the soil vapor extraction system is kind of dual phase, where it not only extracts these vapors off the soil to remediate the contaminants, but it also prevents migration of the volatiles into the air, and it protects the workers as well.
I'm gonna open up the valve, and I'm gonna stick my PID in to get a reading of this tank. And then we move over to the next tank. And it's reading 0, which is what we want.
Traditional approach would be to do injections in the surface, but because these fractures are so small, it's difficult to get anything into those fracture paths. What we proposed was to actually use pneumatic fracture enhancement to not only open up the fractures to allow injection material to get into those fractures more easily, but also to free the contaminant that was trapped in the rock. Collecting these samples, monitoring the systems, making sure that the receptors are protected.
In the next couple of years, we're going to implement a full-scale injection program in order to treat not only the source, but off-site contamination as well.